Okay, this is Unit 9, Day 7, solving rational equations. So we've been doing some work with rational expressions, and now we're going to do some solving. So we're going to solve for x. So our learning target here is I can solve rational equations and recognize extraneous solutions. Remember, extraneous solutions are when you solve it and it says x equals something, but when you plug it in, it actually doesn't. It doesn't work. It's not a true statement, so we throw those out. The main idea here is them being, these being rational expressions on both sides, is we want to get a common denominator, and then once we have common denominators on both sides, we just ignore the denominator. We're done with it. Okay, so this first one, kind of a simpler one, the least common multiple, or the least common denominator of 5 and 8 are 40, or is 40. So what I'm going to do is I'm going to multiply both sides by 40. So I'll multiply this side by 40, I'm going to multiply this side by 40. So I just multiplied both sides of the equation by 40. Now the canceling that happens on the two sides are very different though. It's like 40 over 5 is 8, and then 40 over 8 is 5. Now it's not really a coincidence, or it is a coincidence, I guess. I'm not sure what I should say with that. But multiply by 8, multiply by 5. And some of you might remember when you have a proportion, you multiply cross products and set them equal, and that's exactly what we just did. It's a little harder to see that. Like if I said multiply cross products here, it's kind of ugly, so we kind of do it this way. But so this would be 8 times x equals, and then 5x plus 15. Okay, and again, they're both over 40. So if they're both over 40, I'm not going to write it. I just ignore that. Okay, they had the same denominator, so just throw them out. Okay, so let's see here. So this, if I bring the 5x over, so 8, I'll just rewrite it. Subtract 5x, subtract 5x, so it'd be 3x equals 15, divided by 3, x equals 5, okay? So x equals 5, and what we want to do is just double check, these extraneous circumstances, which I won't show every one of these, but this one I'll show, is we want to plug it back in the original equation. So if I plug it back in, 5 over 5, does that equal 5 plus 3 over 8? And that one does, because 8 over 8 equals 5 over 5, which is 1 equals 1. So that is a true statement. Okay. Here, we're looking for least common multiples again. Now, this one's kind of ugly because the least common multiple of this one, well, if I take a 2 out of here, that'd be 3x plus 1. This one, nothing doing with that. There's no factoring, so multiplying all these together would be the least common multiple. So I could write it the long way, but really if I write the entire least common multiple out, so 2 times 3x plus 1 times 3x squared plus 11, well, the 3x plus 11 cancels out. So almost I just think of what's it missing. This time it had this, it was missing those two, so that's what I multiply by. Over here, this denominator had these two, it's missing that, so that's what I multiply by. So I'll multiply by 3x squared plus 11. Which again is setting cross products equal. We're doing the same thing as what we did in middle school. So this would be 2 times 3x squared, which would be 6x squared plus 22. And that would equal, let's see, so this is going to be 6x plus 2. And then distributing x out, so it would be 6x squared plus 2x. When I multiply that out. Okay, now they both have a 6x squared in there, so I can subtract 6x squared. So those are gone, and now I've got 22 equals 2x divided by 2, x equals 11. And if you plug those back in, again, plug those back up in the original equation, you end up getting 2 over 66 plus 2. Does that equal 11 over 3 times 121 plus 11? So does 2 over 68 equal 11 over 374? And if you divide these And you put them in a calculator, you get the exact same decimal. So these are the same fraction. If you reduce them down completely, they end up being the same fraction. So this is a solution. Number 3, so least common multiple. This one, if I factor this would be x minus 2. So the least common denominator here would be 2 times x minus 2. So if you want to think of what do we need to multiply by, well, this already has both of those to the top. I don't need to multiply that by anything. But this one over here, it has the x minus 2, it's missing the 2, so I'm going to multiply by 2. I could have written 2 times x minus 2 and then do canceling, but this is what would have been left, so it's a little bit faster to do it this way. So the left side here, I get 4 equals, and then 2 times 1 is 2. If you notice, there's no variables to solve for, and that's not a true statement. So that, cross it out. 4 does not equal 2, so that means there's no solution. Now, some of you might be thinking, I like that idea of just setting cross products equal. Okay, that just makes more sense. So if I went back to the drawing board and I did cross products equal, so 2x minus 4 times 1, set that equal to 4 times x minus 2. Okay, and do some solving here. So yeah, 4 equals, when I divide by 2, I get x equals 2. Now, why did I get no solution over here and I get x equals 2 here? Well, if you go back and you plug 2 in, watch what happens. These denominators, if I plug in a 2, 2 times 2 is 4, 4 minus 4 is 0. So that means the original equation would be 4 over 0 equals 1 over 0. If I plug a 2 in here, that's 0. In this, I can't calculate, so that means 2 is not a solution. So that's one of those extraneous solutions that we have to throw out. So no solution is the right answer. Number 4, so I've got 3 times x plus 1. Here I've got x plus 1, x minus 1. So the least common denominator would be 3 times x plus 1 times x minus 1. Okay, so think about what are you missing. So on this first one, I have the 3 of the x plus 1. I don't have the x minus 1, so I'm going to multiply it by x minus 1. Over here I have x plus 1, x minus 1. I don't have 3, so I'm going to multiply that by 3. And now, since I did that, they're over the same denominator. I'm just going to forget the denominators. Just look at the numerators. So 4x minus 4 equals 36. So 4x equals 40. So x equals 10. Again, I said I want to kind of speed things up. If I plug that back in, it does work. So those two sides do balance out, so you don't need to, don't have to throw anything out. Number 5, if I do some factoring, I get cx plus 2x minus 2, so just factor the denominators. So that means my least common denominator would be 3 times x plus 2 times x minus 2. Again, look for what's missing. Okay, this first one is missing the x minus 2. The second one's missing a 3. So that's what I multiply by. So I got 3x minus 6 equals 12. So x equals 6. Again, if you plug those back in, I've already checked it. It does work. It does equal. You still need to do it for your homework to double check on the ones that ask you for that. If they ask about extraneous circumstances, make sure you plug it back into the original equation and check it. I'm trying to save time, so I'm going to skip that. X minus 3, this would be x minus 3 times x plus 3. So the least common denominator is x minus 3 times x plus 3. So the first one has the x minus 3, it's missing the x plus 3. The second one's not missing anything, so I'm going to leave it at 6x. So I got x plus 3 equals 6x. Oops, minus x. Divided by 5, so 3/5. Again, I checked it. I'll put a check mark there because when I did the first time I plugged them back in, it gets kind of ugly, but the decimals are exactly the same when I plug them back in. Okay. I'm missing my backside here. Here we go. I thought that was two-sided, and it's not. Here we go. So, a little bit easier of a question, different problem. It looks different. You notice the front side, there were only fractions on each side had one fraction. Here, there's two fractions on the left side. but treat it the same way. So the least common denominator, can almost do this in your head, is 10, between 2 and 5. So I'll multiply everything by 10. Well, this 5, it already, think the factors of 10 already has a 5, that means it's missing a 2, so we'll multiply by 2. This one already has a 2, it's missing a 5, and this one I'm going to multiply by 10. So now they have the same denominators, I'm just going to throw them all out. So it would be 2y plus 5y equals 70. So 7y equals 70. So y equals 10. Okay, it's like my screen froze for a second, but that's okay. Again, if you plug that back in, it does work. If you plugged in 10, 10 divided by 5 is 2. 10 divided by 2 is 5. 2 plus 5 is 7, so it works. So that balances out. This guy here, the least common denominator would be between 4, and this is actually a 1 and 8. 4, 1, and 8 is 8. So I'll multiply everything times 8. So when I multiply this first one by 8, the 8 and the 4 would reduce to 2. This one I need to multiply by 8. And this one, if I multiplied by 8, the 8 would just go away. So I'm not doing anything with it. So I've got, so it'd be 2 minus 8x equals x. After I multiply everything, add 8x to both sides. So 2 equals 9x. Okay, 2/9. Again, I did check that. I plugged it back in. It was weird decimals, but it did balance out. 9 and 10. Again, we're going to see how well you understood day 6, because this is kind of what you did in day 6 was, what's the least common multiple of all of this stuff? Well, the least common denominator, I think 2x, 3x, and 6, if you look at the x's alone, x to the first power, if you're looking at 2, 3, and 6, 6 is the least common multiple. So the least common denominator, let me write that a little more clear, is 6x. So I'm going to multiply everything by 6x. So 6x here, and then 2x, when I reduce, would be a 3. So multiply by 3. 6x and 3 would reduce to 2x. 6x and x would be a 6, and then 6x and 6 would be just an x. So I got 15 minus 4x would equal 6 plus 5x when I simplify all that. Add 4x to both sides, subtract 6 from both sides. I got 9 equals 9x. X equals 1. And then this last guy here, what's the least common denominator of 5x, 3x, and 3? Again, look at the numbers first and look at the variables. So 5 and 3, well 3, the least common multiple is 15, and then x, well the highest powers in 1 would be 15x. So I'm going to multiply this by 15x, but when I reduce, when I divide by 5x, that would just be a 3. Here, 15x divided by 3x would be a 5, and then 15x divided by 3 would be a 5x that I'm multiplying by. So I'd get 9 minus 20 equals 5x. So negative 11/5. Again, I did check it. I plugged it back in at the calculator and just looked at the decimals, make sure the decimals are equal. Okay, now a word problem. Don't be overwhelmed by these. These are not as, a lot of times we look at word problems and we just give up and throw our hands up and, and say it's too much. But this guy here, they kind of all follow the same pattern once you get it. It says that you shovel a driveway in 5 hours. Your friend across the street can do his driveway in 4 hours. How long will it take the two of you if you work together to get both driveways done? Okay, so you think about, you're going to take your work plus your friend's work, and that's going to equal the total work that needs to be done. Well, your work, think about in hours. So every hour that passes, you do 1/4 of a driveway per hour, so times x. If you kind of shorten that up, 1/4 times x is just x over 4. To kind of write it shorter. He can do, I'm sorry, that's your friend. I'll say this is your friend. You can do 1/5 of a driveway per hour, because it takes you 5 hours to do the whole driveway. Well, that's just x over 5. So your work, so every hour that passes, you do 1/5, they do 1/5. Well, how many hours does it take until your work plus their work equals the two driveways? That's kind of what they're saying. Okay. So least common denominator I mean, just treat it like you did the problems above. Like treat it like these guys, like this one here, even a lot like that, kind of the same thing. Least common denominator would be 20. So I'm going to multiply everything by 20. When I multiply this by 20, the 20 to the 5 would reduce to 4. When I multiply this by 20, the 20 and the 4 would reduce to 5. And then here, this is over 1, so I need to multiply that by 20. So this would be 4x plus 5x equals 40. So that means 9x equals 40 divided by 9. So you could say 40 over 9. If you want to get real fancy, you could do 4 and 4/9. On your calculator, it'd be 4.4 repeating. Whoops, going off the screen there. So yeah, 40/9, or 4 and 4/9, or 4, and then 0.4 repeating hours.